Hello guys, in this tutorial I'm going to solve the question number 7, paper 32 May 2017. Prove that if y equals 1 over cosine theta, so dy by d theta is equal sec over 10. Actually, the first part, 1 over cosine, this is sec. So when I ask you to differentiate sec or get sec x, we start from this part. Let's start now. Y is equal to 1 over cosine theta as it's written. We'll apply now quotient rule. We have 2 u over v. So u dash times v minus v dash times u divided by v squared. So dy by dx is equal to fraction. Derivative of first is 0 multiplied by cosine theta. Derivative of cosine is negative sine theta divided by cosine squared theta. So negative is positive, sine theta over cosine squared. Cosine squared split it as cosine theta and cosine theta. So 1 over cosine theta is sec, and the sine over cosine is tan. So the final answer now is sec theta tan theta. So the derivative of what? Derivative of sec. So when I ask to integrate sec theta tan theta, just write directly sec theta or 1 over cosine. Part 2, prove that the identity 1 plus sine theta, 1 minus sine theta. If we start with the left-hand side, to get the right side, by looking at the left, it's not included squared, but the right side included squared. So if we start with the left-hand side and multiply by the conjugate of the denominator and expand, simplify, you will get square. So I will start now with the left-hand side. For the left-hand side, which is 1 plus sine theta divided by 1 minus sine theta, multiplied by the conjugate of the denominator, which is 1 plus sine theta divided by 1 plus sine theta. If we expand the numerators and the denominators together, you will get 1 plus 2 sine theta plus sine squared theta, because it is 1 plus sine theta, the whole squared, divided by 1 minus sine squared theta. Take your time to expand 1 by 1, but you can write mentally your answer directly, because this is 1 plus sine theta is a perfect squared, so you can use identity a squared to ab plus b squared. And also the denominator, it's a difference between two squares. It's a minus b and a plus b. So if you expand, will be a minus b squared. Try to use the identities each time. Now, this is the left-hand side. Still, we have to remove the denominator. It's 1 minus sine squared. So you can use identity of Pythagoras. 1 sine squared plus cosine squared is equal to 1. Sine squared theta plus cosine squared theta is equal to 1. So 1 minus sine squared is cosine squared. The numerator is 1 plus 2 sine theta plus sine squared theta, all divided by cosine squared theta. Now you can distribute the numerator over the denominator and write it like this: 1 over cosine squared theta, 2 sine theta divided by cosine squared theta, and sine squared theta plus cosine squared theta. Simplify. 1 over cosine squared, it's sec squared x theta. 2 sine over cosine, you can write it as sine cosine sine over cosine. So sine theta over cosine theta, you can remove it and write tan. 1 over cosine theta, you can write it sec. Sine squared over cosine squared, use it as tan squared theta. So the final answer is sec squared theta plus 2 sec theta cosine theta plus tan squared theta. But still, if you look at the right side, it's included here 2 sec squared. and they removed tan squared because we have identity connected between tan and sec. 1 plus tan squared theta is equal to sec squared theta. Remove tan and write it sec squared minus 1. So sec squared theta plus 2 sec theta cosine theta plus remove tan and write sec squared theta minus 1. Simplify sec squared, and the sec squared is 2 sec squared theta plus 2 sec theta cosine theta minus 1. This is the final answer, which is right hand side same. Hence, integrate. We have integration by limits 0 and 4th pi. Sure, because we have part 1 and part 2. Don't forget to use it part 3. Even the examiner written here, hence, this means you have to use maybe part 1, 2, or both to solve this question. So instead of integrate this part, I use integration this part with the right hand side. 2 sec squared, 2 sec squared, integration of 2 sec squared theta plus 2 sec theta plus 2 sec theta cosine theta minus 1 all by d theta. How to use part 1 and part 2? Already now use part 2 after removing this expression and write the right hand side. Let's start now to integrate. Integration of sec squared is tan, because differentiation of tan is sec squared. So will be 2 tan theta. If you look at part 1, the derivative of 1 over cosine. So you can use it sec 2, differentiation of sec cosine. Sorry, it's sec sine. I forgot to remove sine over cosine. I don't know how I wrote it cosine theta here. It's tan theta. This part, it's tan theta. This part, it's tan theta. Now, if you integrate, when I look at this part, it's tan, which we can use it as integrate of sec, or we can write it as 2 or 1 over cosine. The derivative of 1 over cosine, it's sec tan. Minus integrate of 1 will be theta, but we have limits from 0 to 4th. Start to use your calculator and rad system. Write theta is 4th pi. So 2 tan pi over 4 plus 2 over cosine pi over 4 minus pi over 4. Then minus 2 tan 0 plus 2 over cosine 0 minus 0. You can use your calculator. Tan pi over 4, which is equal to 1. 2 over tan pi over 2 is 1 over root 2. So write it like this, 1 over root 2 over root 2 over 2, and simplify your answer. Minus pi over 4. Tan 0 is 0. Cosine 0 is 1. So the answer will be 2. Simplify more. Minus 2 plus 2 cancel. 2 root 2 minus pi over 4. If he asks you to write your answer exact, so please keep it exact. It's not, yes, it's written. Find the exact value. So keep your answer exact. If it is not written and you write, you can write your answer correctly to 3 significant figure. Thank you.